critical temperature, critical pressure, and eccentric factor of moisture. Moisture consists of dry air and water vapor. So now we have in the previous section we understood how to calculate these properties for the dry air, and we also know the value for the water vapor. So we can calculate critical pressure, critical temperature, and eccentric factor of moisture. So now these properties, the main property, this is a pressure temperature diagram of the gas mixture. So main properties of gas involved are critical pressure, critical temperature, and eccentric factor. Critical pressure is defined as a pressure at which liquefaction of gas is done at the critical temperature, and critical temperature is defined as temperature above which liquefaction of gas is not possible no matter how much pressure is increased. It is to be noted that above the critical point, gas cannot be converted into liquid. Eccentric factor is a property of the gas which measures the non-sphericity, that is centricity of the molecules, and due to this boiling points gets elevated. Eccentric factor takes care of this. That means each gas component has a certain value of critical pressure, critical temperature, and eccentric factor. To find these properties of the gas mixture, mole fraction of each gas component is multiplied with these properties and adding them up to get the properties of the gas mixture. Critical temperature, critical pressure, and eccentric factor chart is available for reference and use. Steps to be followed for critical temperature, critical pressure, and eccentric factor of the moisture. Moisture is considered a mixture of two gases. One gas is dry air, which has mixture of the gases is considered dry air, and another is a water vapor. To find out the mole fraction of each of the gas component, multiplied mole fraction of each gas with its critical temperature and add them to get the critical temperature of the gas mixture, that is moisture, multiplied mole fraction of each gas with its critical pressure and add them to get the critical pressure of the gas mixture, that is moisture, and multiplied mole fraction of each gas with eccentric factor and add them to get the eccentric factor of gas air, that is a moist air mixture. Now the critical temperature, critical pressure, and eccentric factor. Dry air properties we know, we have just calculated in the previous section. Critical temperature TC1 is 132.44 degree Kelvin. Critical pressure PC1 is 37.064 bar absolute, and eccentric factor W omega 1 is equal to 0.036 constant. Water vapor properties we can take from the chart or table. Critical pressure TC2 is 647.7 degree Kelvin. Critical pressure PC2 217.6 bar absolute, and eccentric factor omega 2 0.344 constant. Now the moisture property, the critical temperature Tc will be Tc1 into bracket start 1 minus n bracket close plus Tc2 into n, where n is a number of mole fraction of water vapor. Now critical pressure Pc is equal to Pc1 into bracket start 1 minus n bracket close plus Pc2 into n, and eccentric factor omega is equal to omega 1 into bracket start 1 minus n bracket close plus omega 2 into n, where n is a mole fraction of water vapor. Now understanding with an example, calculate the critical temperature, critical pressure, and eccentric factor of moisture of pressure 1.1 bar absolute and temperature 30 degree Celsius with relative humidity 80%. So pressure P is 1.1 bar absolute, which is 110 kilopascal absolute. Temperature is 30 degree, relative humidity RH is 80. Using Buck equation, saturated water vapor pressure PVS is calculated, which is coming as 4.24 kilopascal absolute, and unsaturated water vapor pressure is based on RH, which is coming 3.39. Mole fraction of water vapor N is Pb upon P, So it is coming as 3.39 divided by 110 is equal to 0.031 constant. So N is now known. So critical temperature of moisture is equal to critical temperature of dryer into 1 bracket start 1 minus N bracket close plus critical temperature of water vapor into N. So putting all the data, critical temperature is coming as 148.409 degree Kelvin. Critical pressure of moisture is equal to critical pressure of dryer into 1 bracket start 1 minus N bracket close plus critical pressure of water vapor into N. So putting all this value, critical pressure is coming as 42.661 bar absolute, and eccentric factor omega of moisture is equal to eccentric factor of dryer into bracket start 1 minus N bracket close plus eccentric factor of water into N. So putting all this value, eccentric factor omega is coming 0.046 constant. So hope you have understood how the properties, that is critical temperature, critical pressure and eccentric factor of the moisture is calculated. So first of all you have to calculate the mole fraction of water vapor, and based on the all the known properties we can calculate the critical temperature, critical pressure and eccentric factor of the moisture. So hope you like this. Thank you. Thank you for watching.